welcome to my channel, this noble hero. Okay, so we're talking on binomial expansion. Well, in our last video we had talked about Pascal triangle, and so let's continue with binomial expansion now and see how we can apply this. All right, now for binomial expansion, let's say we have x plus y to the power of n, and we are to expand this. Now, the power here could be a fraction, could be decimal. So, unlike Pascal triangle that only deals with whole numbers, power that are whole numbers, binomial expansion help us to solve or to expand equations that the power is a fraction. All right, to be able to form the binomial expansion, the formula, we will need to know or recall a particular formula, combination formula that goes this way: n factorial all over n minus r factorial r factorial. So we need to take note of this. And going a little bit deeper into factorial and what it means, I'd like us to talk a little about factorial. All right, so for instance, now we have 6 factorial. Now 6 factorial would be equal to 6 times 5 times 4 times 3 times 2 times 1. Okay? And then 5 factorial would be equal to would be equal to 5 times 4 times 3 times 2 times 1. Okay? 4 factorial would be 4 times 3 times 2 times 1. And so, based on what we've done so far, we would observe that any factorial term, let's call that factorial n, since we don't want to use a specific number. Any factorial n would always start with that number n. 6 factorial 6, 5 factorial 5, 4 factorial 4. So n factorial should start with n. And then this n should multiply to the next number, the subsequent number that is below it. Okay? So this 6, now we know that 5 is the same thing as 6 minus 1, right? 5 is 6 minus 1, 4 is 6 minus 2, 3 is 6 minus 3, 2 is 6 minus 4, and 1 is 6 minus 5. Okay? So which means that 5 here, we have 4, which is same thing as 5 minus 1, 3, 5 minus 2, 2, 5 minus 3. So which means that the next number should be n minus 1. 4, 3 is the same thing as 4 minus 1, 2 is the same thing as 4 minus 2. So the next one should be n minus 2. And this should continue that way until you have 2 and 1. 2 times 1. Alright? So this is your factorial. Now, another thing we want to look at is that in 6 factorial, there is 5 factorial. There is 5 factorial in 6 factorial. So, after writing 6, multiplied to the rest of this is 5 factorial. From here down to the end there is 5 factorial. In 6 factorial, there is 4 factorial. From this point to this point is 4 factorial. 4, 3, 2, 1. 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Okay? Now, what it means now is that I can decide to write 6 factorial as 6 multiplied to 5 factorial, because this 5 factorial means 5, 4, 3, 2, 1, which still completes your 6 factorial. Okay? Or I can decide to say 6 multiplied to 5 multiplied to 4 factorial. Okay? Which in this case, we're going to write this as 30 times 4 factorial. Now, I'm not going to multiply this with this. Okay? Why I'm not going to multiply this with this is because this contains a factorial. Okay? Alright, so 6 is an ordinary number now, 5 is an ordinary number, so I can multiply them to 6 times 5, and 4 here carries factorial, so I'm not going to multiply it to it, so I need to say 30 times 4 factorial. Alright, but what I really want you to take note of is that if you stop at a point and you don't want to continue again, you have to add factorial. Is that okay? Alright, so for instance, we can then say that n factorial can be written as n minus 1. I can decide to stop it here. All I need to do is to add factorial. If I don't want to stop it there and then I continue, I can add my factorial here if I want to stop it at this point. If I don't want to stop it at that point and then still go on, I have to add my factorial. So I can decide to add factorial at any point that I decide to stop. Okay? Alright, that means I don't want to take it down to 2 and 1. So I can stop at any point. That's what I want us to take note of. Okay, so to expand this using binomial formula, we'll start by saying we're going to say n combination 0. We're starting with n, which is the highest power, combination 0. Okay? Alright? And then now, this stands as coefficients, just like we've been doing before. Coefficient, first variable, second variable. So this stands as a coefficient. Now the first variable is x, and x is going to carry the highest power, which is n. And then y is going to carry the power of 0. You can still recall what we did in Pascal triangle. And then we'll continue again with the coefficients. Now the next coefficient is going to be n combination 1. So here is n combination 0, n combination 1, so you know what's coming next. Alright, now x, now the power would decrease by 1. And when you say decrease by 1, that means we're going to subtract 1 from it. So if you say something is going to decrease by 1, you just need to subtract 1 from it. Alright, so the power is going to decrease by 1, while the power of y is going to increase by 1. So from 0, if you add 1 to 0, it becomes 1. And then n combination 2, x will now be n minus 2, y will be equal to y raised to the power of 2. Next coefficient, first variable n minus 3, second variable 3. Alright, with what is going on here, I think there is a relationship here. You have 0 here, you have 0. Now n here is the same thing as n minus 0 because n minus 0 is still 0. So n minus 0, n minus 1, n minus 2, n minus 3. So the numbers that repeats there is n and 0. In this one, n and 1, 1, n and 2, 2, 2, n and 3, 3, 3. Alright, so at any point in time, x here will carry the power n minus r, n minus 3. Y is going to carry the power. So here the power will be r. Okay? So this will continue like that way. So this will continue this way until r here, remember, is increasing from 0, 1, 2, and the highest number there is n. So it should have increased to n. and then x will now be n minus n, and n minus n should be 0. So the power of x will now be 0, and the power of y would be n. Okay, so now this is the formula, and if this is simple to recall, then you don't have any issue. You don't have any issue with binomial expansion again. If you can recall how to form this formula, then you shouldn't have any problem again with binomial expansion. Okay? Alright, so let's put in the values of n combination 0, n combination 1, n combination 2, n combination 3. What are we talking about there? Alright, so let's start by saying what's n combination 0. N combination 0, using the formula here, n combination r would be equal to n factorial. That means what we have up here, factorial. So what we have here is n. So I'm going to say n factorial over n minus r. And our r in this case is 0. So n minus 0 and then 0 factorial. And please, let's take note that 1 factorial is equal to 1. Also, 0 factorial is also equal to 1. So let's take note of that. That will help us. So let's take note of this. Okay, so with this, we have n factorial on the numerator. Sorry, there's a factorial here. On the denominator, we have n minus 0, and n minus 0 is still n. And then we have 0 factorial. Alright, so like we said, 0 factorial is 1. And 1 times n factorial will still be n factorial. So this is the same. Numerator and denominator is the same. So the answer there is 1. So this is what we have for n combination 0. N combination 0 is 1. Now what's n combination 1? This will be n factorial all over n minus 1 factorial 1 factorial using this formula. Okay, where r in this particular case is 1. Okay, all right, and 1 factorial is 1, so 1 multiplied to this, and what we have here is n factorial all over n minus 1 factorial. So in this particular case, we need to work on the factorial here. So we start by saying n factorial will mean n multiplied to n minus 1. Now we have to hold on first. Why are we holding on? We have n minus 1 on the denominator, so we'll need to stop at that point, and then if we are stopping at that point, we need to add factorial. And let's go below. We have n minus 1 factorial. So in this case, we can easily divide out the ones that have factorial out, so that we are only left with n. So n combination 1 is equal to n. Then we can continue now with n combination 2. So we have n combination 2, and this should be n factorial all over n minus 2 factorial 2 factorial. Okay, so in this case, we're going to start with n, and n factorial is the same thing as saying n into n minus 1. I'm not going to stop there. The next one should be n minus 2. Now I'm going to stop there. I'm going to add factorial because of this n minus 2 that is on the denominator. So on the denominator, we have n minus 2 factorial 2 factorial. So in this case, n minus 2 factorial will cancel out n minus 2 factorial, and we are left with n into n minus 1 divided by 2 factorial. And 2 factorial is the same thing as 2, because 2 factorial is 2 times 1. Okay? Alright. So we have this, and we have that. So I will appreciate if you can check what n combination 3 is, and then you drop your answer on the comment section, please. Really appreciate that if you can do that for me. Alright, so what is n combination n? So we check out for n combination n. This should be n factorial all over n minus n factorial n factorial. Now this should give us n factorial. N minus n is 0 and n factorial. Now 0 factorial is known as 1, so we have n factorial all over n factorial, and this equal to 1. Okay, alright, so now we can then go on to say that this would be 1, this is 1, so 1 multiplied to this remains x raised to the power of n, and y raised to the power of 0 is also 1, so everything multiplied to this will remain this. Then we go to plus. This was equal to n. In combination 1 was equal to n. So we have n multiplied to x raised to the power of n minus 1, y. Y raised to the power of 1 is y. Alright, now n combination 2 was known to be n into n minus 1 divided by 2. And then we have x raised to the power of n minus 2 and y raised to the power of 2. Alright. So if you did this correctly, this should have been equal to n into n minus 1 into n minus 2 divided by 6. And then here we have x raised to the power of n minus 3, y raised to the power of 3, plus dot dot dot. And then this will go down to x raised to the power of 0 is 1, this is 1, and we are left with y raised to the power of n. Alright, so this is your binomial expansion, and this is the formula for it. Now the question is, do you have to quote this? You have to cram this formula. I'll tell you no, you don't have to cram the formula, but when you use it continuously, the formula will find its way into your memory. But all you really need to take note of is this simple part. Take note of the simple part, take note of this, and you're done. Take note of this, take note of this, and how to apply all this. And you'll be able to form this formula anytime. Alright, so now we'll have to go into application of this formula. How do you apply these this formula? Alright, so let's say we have to solve expand the square root of a plus b. If we have to expand the square root of a plus b, now your question would be, what's the power there and what are we really expanding? Now, when you have a square root like this, it can also be represented as a plus b, and the power there is 1 over 2. Okay? Now this is square root, and the square root here, the power of the root now is 2, and the power of the root is 2. This forms the denominator. This forms the denominator of the fraction of this power. So which means that if you have something like this, this will be written as a plus b to the power of 1 over 3, because this is going to form the denominator of the fraction of the power. Denominator of the fraction of the power of this. And if there is another power here, 2, that power will be reflected at this point. Okay. So now we're going to work on this. And I know most of you don't like fractions, but let's try. Alright. So now, let's recall the binomial expansion formula again. Binomial expansion formula says x plus y raised to the power of n would be equal to x raised to the power of n plus n x to the power of n minus 1 y plus n minus 1 all over 2 x to the power of n minus 2 y raised to the power of 2 plus n into n minus 1 into n minus 2 all over 6 x raised to the power of n minus 3 y raised to the power of 3 plus it continues that way until it is y raised to the power of n. Alright, so how do you apply it to this point? Now you can keep it at this point, or you can keep it as a fraction, or you can also keep it as decimal, depending on which one would be of ease to you. Alright, so now using this formula, we'll start by where, or let's put it down here, where in this case where a, or where x here is a and y is b, n is 1 over 2. Alright, so we start with x, which is a, in this particular case a, and then the highest power there is 1 over 2. So put down 1 over 2 plus n, which is 1 over 2, the power 1 over 2 multiplied to a, and then n minus 1, which is 1 over 2 minus 1. Okay, that's not done. They're not done yet. We'll write y, and our y is b. So put it down, b plus, at the next point we have n, and our n is 1 over 2 into bracket 1 over 2, which is n minus 1 divided by 2 again, x raised to the power of n minus 2, and n minus 2 here is n is 1 over 2, y raised to the power of 2 plus, at the last point here we have 1 over 2 multiplied to 1 over 2 minus 1 into 1 over 2 minus 2 all over 6. Then we have x raised to the power of 1 over 2 minus 3, and then our y, which is a, sorry for mixing up the letters here, b to the power of 3 So in this particular case, x is equal to a, b, y in this formula is equal to b, and then n is equal to the power 1 over 2. Okay, all right, so let's introduce it into this formula. So introducing it into the formula like this, we start with x, which is our a, to the power of n, which is 1 over 2, plus n, which is 1 over 2, multiplied to x, which is a, raised to the power of 1 over 2 minus 1, which is n minus 1, and then y, which is b, raised to the power of 1, so that's it, plus n, which is 1 over 2 again, multiplied to 1 over 2 minus 1, divided by 2, x is a, raised to the power of 1 over 2 minus 2, and y is b, raised to the power of 2. Okay, plus this point we have 1 over 2 multiply to 1 over 2 minus 1 and 1 over 2 minus 2 all over 6. X is A, N is 1 over 2 minus 3, Y is B raised to the power of 3, plus continue that way until Y, which is our B, is raised to the power of 1 over 2. Okay. So you can continue now by one over 2. Now we have 1 over 2 here. So the coefficient is 1 over 2, and our A is the same thing as 1 over 2 minus 1. And 1 over 2 minus 1 is the same as negative 1 over 2. And then we have B, put it down, plus one over 2 minus 1 over 2, 1 over 2 minus 1, which we had here already, is 1 over 2, minus 1 over 2. 1 minus 1 over 2 times 1 over 2 is minus 1 over 4. So we have a negative 1 over 4 divided by 2. And then we have A raised to the power of 1 over 2 minus 2. So 1 over 2 minus 2, the LCM is 2. LCM is 2. Then 2 divided by 2. 2 divided by 2 is 1. 1 times 1 is 1. 2 divided by 1 is 2. 2 times 2 is 4. So this is negative 3 over 2. Alright, so we put it down there as negative 3 over 2. B raised to the power of 2. For this point here, this is negative 1 over 2. This is negative 1 over 2. This is negative 3 over 2. So at the end of the 3 here is 1 over 2, negative 1 over 2, and negative 3 over 2. Together on the denominator, we have 2 times 2 times 2, which is 8. 1 times minus 1 is minus 1. Minus 1 times minus is 3. So we have 3 over 8. So the whole of this would be 3 over 8 divided by 6 here. Then we have A raised to the power of 1 over 2 minus 3. Now 1 over 2 minus 3 would be the same as 2 into 1 minus 6, which is minus 5 over 2. So A would be minus 5 over 2. And then B would be raised to the power of 3. And then it continues that way until you reach B raised to the power 1 over 2. Alright, so finally, this would be the same as A raised to the power 1 over 2 plus 1 over 2 A raised to the power minus 1 over 2B. And this would be the same as negative, because of negative, positive is negative. And this would be the same as 1 over 8 A raised to the power minus 3 over 2 B raised to the power of 2 plus this would be the same as 3 over 40 3 over 48, and 3 over 48 is the same as 1 over 16. So this will be the same as 1 all over 16. We have A raised to the power minus 5 over 2 B raised to the power of 3. And it continues that way until we reach B raised to the power 1 over 2. All right, so that's the application of it, and although it's a little bit stressful, simple, we just need to be careful while solving it. All right, so we'll have another video that will cover another example. All right, another video that will cover another example, but I want to know if these have been helpful and if there's any way, if you need more, additional assistance, please don't hesitate to contact me. All right, so take care of yourself. Please subscribe and like the video. Recommend it to those that to be helpful too. Thank you.